Plus 3. And 4, 3, 3. Very good. I think this is it, right? Yeah. Okay. So 9 times 2.
Hey guys, I'm sorry I'm late. All right.
6 times 2 plus 1. Put your 0 in.
All right.
Okay, so what is this? Where did you get that one from? Yes, it was from the first time. Look. 2 times 9 is 18, carried you 1. 2 times 6 is 12, carried you 1 is 13. Now cross that one out. You don't need it anymore. You added your 0. What is 1 times 9? 9. What is 1 times 6? That's what went wrong.
All right. What
Go ahead and fix it.
does anybody want to see any problems?
Draw the line, add the sign, total it up.
Come in, Tokyo. All right, I'm just going to do some problems then.
All right, so here we go.
Here we go. Let's do some implicit differentiation. Okay, so let's do something like this. 2x
Try to do that on yourself and then I'll check it.
cubed plus 3y cubed equals 64. And I need to find dy dx. Okay, so I'm going to differentiate down the line. The derivative of this is 6x squared dx dx, so I leave that off, plus this is 9y squared dy dx, and the derivative of 64 is 0. Now you want to collect your dy dx and move everything else to the other side. Okay, so I just kind of move that over, and then I divide by that. So that is dy dx. Okay, so that's a good warm up. So always be mindful of what I'm asking for. I could ask the same question like this. 2x cubed plus 3y cubed equals 64. Okay, it's the exact same question, but I could ask, what is dx dt? In which case, this changes everything. The derivative of this is 6x squared dx dt plus 9y squared dy dt equals 0. And then again, I want dx dt. So I'll throw this over here. So it would be 9y squared dy dt, and then I divide by 6x squared. Okay, so in this case, I have kind of a different answer. All right, it's this, and that's okay. And then I could probably give you values if I wanted to, but just always, the point of this is know what I'm asking for. In this scenario, I was asking for dy dx, so I get dy dx by itself. That's the answer. Same problem, I was asking for dx dt. Okay, and Yes, thank you. All right, here's my equal sign. All right, that would be Ariana Medina. All right, good job, Ari. Okay, so again, the point is make sure you give me what I'm asking. All right, I have Ari looking for number 8 from page 194. 194. And we're doing number 8. Okay. All right. Number 8 from page 194. Okay, here we go. Number 8 is y equals cosine of x. Okay. They tell you dx dt is 4. And the snapshot is when x is pi 6. All right, here we go. Let's go through and differentiate. So the derivative of y is dy. Remember, everything's with respect to time. So that's dy dt. Okay. And dx dt. And then, sorry, I was looking at the directions, what they were wanting. All right, and then the derivative cosine is negative sine of x dx dt. All right, when we plug everything in, sine of 30 is what? 1/2, okay? And dx dt is 4. So that would be negative 2. That's what dy dt is, okay? Now, yeah. Is that all right? All right, good. All right, and then Dean, I see Dean here. Can we try number 8 on page 179 after? All right, so let's go back to 179. All right, so this, scoot up here. So what is 6 times 3? On 179. All right, here we go. 8. All right, so we got square root of x times y equals x squared y plus 1. Okay, and they're asking for dy dx. Okay, all right, now we just got to be careful, keep track of everything. I would take this front one and we rewrite it as x times y to the 1/2 power. Okay. This is a product rule. So I'm going to break it up, x squared y plus x squared y. And then I have the plus 1 out here. Okay, so I'm differentiating that. Do it first, the second, and then doing that. All right, this, guys, is unfortunately is going to be like chain rule. All right, so here we go. 1/2 out front. Leave that alone. Subtract 1 from the power times the derivative of what's inside here. Okay, well, the derivative of that is, here we go. The derivative of x is 1 times y, all right, so y, plus, and then the derivative of y is dy dx times x. Okay. All right, so that's just this front part right here. All right. Equals. Derivative of x squared is 2x times y. And the derivative of y is 1 dy dx. Okay. And then the derivative of 1 is 0. Everybody all right? All right, let's clean up a little bit here. And again, what I'm after here is dy dx. So now I've got to figure out algebraically to get dy dx by itself. So let's clean this up. So this becomes 1 over 2 times the square root of xy. All right, and then I have y plus x dy dx.
So
Okay.
7 times 2.
All right, I always get rid of my parentheses here, so I'm going to distribute this through.
Don't forget to put your 0.
So this becomes y
Can I cover that number?
over 2 times the square root of xy
2 times 2.
plus, I'm going to come to this.
4.
All right, and this is going to be x
Add your sign. Total it up.
dy dx over 2 times the square root of xy equals 2xy plus x squared dy dx. All right, collect everything to one side and start moving things around.
5 times 1.
So I'm going to move this over and move this, come over here. So I have all my dy dx's over. All right, I'm going to try and do it in one step here. All right, correct me if I mess up here. All right, here we go. So I've got x dy dx over 2 times the square root of xy. I'll leave that alone.
Make sure that's right. Hold on.
Minus x squared dy dx. Okay, so that's everything here. Then when I move this over, equals minus y over 2 times square root of xy. All right. Pull out a dy dx. Okay, so I got dy dx. And I'm left with x over 2 times the square root of xy minus x squared. Here we go. Now I just divide everything by this mess. I could clean this up a little bit, but I'm looking at this, and that wouldn't really be too nice. And so I'm just going to leave it like this. X over 2 times xy minus x squared. That's the answer. We could clean it up. All right. Let me do that real quick. Okay. So this would be to the 1, and that's to the 1/2. All right. Remember when we're going to do that trick where we multiply, cross multiply and stuff. All right. So when you multiply, you add the powers. Okay. So that's going to be 2 times x y, and what's 1 plus 1/2? 3/2 minus y all over 2 times the square root of xy. The bottom is going to be x minus 2x squared square root of xy all over 2 times the square root of xy. And you're allowed to do this. That cancels with the denominator here. So here we go. I'd have 2 times the square root of xy cubed minus y all over x minus 2x squared square root of xy. Okay? So anyway, that is kind of a beastly one. But look back through this video later and you can kind of see the steps. But I'm okay leaving it like this. Alright? But calculus is not hard. That was the algebra. Alright, now I've got a question. Can we do 12 on page 179? 12. Page 179. We have sine of pi x plus cosine of pi y all squared equals 2. Yuck. Alright, here we go. Alright, I see your question mark. Give me a minute. Yep. Alright, here we go. Again, they're asking for dy dx. So this, unfortunately, guys, is power rule, chain rule. Okay? So 2 out front. Leave what's inside the parentheses alone. Subtract 1 from the power times the derivative of what's inside here. What's the derivative of sine of pi x is going to be what? Cosine of pi x times pi. Remember? Sine of u is cosine of u times u prime. Well, pi is the derivative of pi x. Okay, because it's an x term, you'd have dx dx, which we don't put the differential. Plus, the derivative cosine is going to be negative sine of pi y times the derivative of pi y, which is pi, dy dx. All right, equals the derivative of 2 is 0. All right, so I'm just going to take this right here and just make that a big negative here. All right, now we've got a big mess. Now, one thing you can do right off the bat is this 2. Since this is all a giant product, I can divide by 2. Okay, and they're gone. And 0 over 2 is 0. All right, so now I have this mess times this mess. That is foiling, guys. All right, so here we go. Pi sine of pi x cosine of pi x. Okay, that's my f. My outer is this guy times that, so it's going to be sine of pi x. All right, and it's negative, so negative sine of pi x. But you would think it's sine squared, but it's not, because this is a pi y, so you actually have to write it out twice. And guys, you cannot factor out a pi. This is not pi sine times pi. It's not. It's sine of this. Okay? And it's sine of pi y. All right? Times pi times dy dx. Okay? So this is my f. This is my o. Now my inner is going to be plus, and same issue. This is pi y, this is pi x, so you can't combine that in any way. So I'm just going to do cosine of pi x, cosine of pi y times pi. Alright, then minus, it's a big mess, cosine of pi y times sine of pi y, pi times dy dx. Alright, everyone follow that? Okay, anything that has a dy, that does not have a dy dx, let's throw it to the other side. That would be this guy, and that would be this guy. Alright, so let's put my equal sign here. Alright, uh-oh. Let me plug my battery in, guys. Hold on. Alright, sorry. Okay, here we go. There we go. We're back to business. Okay, so that becomes minus. All right, so that one's moved over. This one would be moved over, so that's also minus pi cosine of pi x cosine of pi y. All right, and on this side, all right, I have negative sine pi x sine of pi y times pi. And I'm going to pull out the dy dx, so hopefully y'all can follow what I did here. So if I pull the dy dx out, I have it here, and so I just have this left. All right, so minus cosine of pi y sine of pi y times pi. All right, let me clean that up. Okay, so then I would just divide by that mess. All right, so I have negative pi. Well, we'll cancel some things here in a minute. All right, negative pi sine of pi x sine of pi y minus pi cosine of pi y sine of pi y. There we go. I just pulled all my pi's out front. So on the top and bottom, I can pull out a negative pi on the top pull out a negative pi on the bottom. They cancel. So that would just do this. Boom, 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 boom. Like that. Okay. Now the top, I have a sine of pi x, I have a cosine of pi x, cosine. So I could factor out a cosine of pi x in the top. Cosine of pi x. And I'd be left with sine pi x plus cosine of pi y. Alright. And on the bottom I can factor out, let's see here, sine of pi y, sine of pi y. Yep, sine of pi. Alright. So that really doesn't help me out any. Because I thought maybe it'd be cosine, so whatever. So you can just kind of leave it like here. Alright. That was a beast. Who asked for that one? Nice. Way to go, Dean. No, number 12. Who did number 12? Ari. Okay. Alright. We won't do something like that on the test. That would take too long. Alright, so the question from Mark is, could you give us an example of the most difficult related question that would possibly be on the test? Alright, well, so Mark, when you ask a teacher the most difficult question, that's very, depends. I'm not sure what you consider hard or what I consider hard. It's all about extracting out the variables. So let me try to find here a problem here. All right, so y'all know there's a moving ladder on there, okay? That's a triangle one. Let's do... Water is being pumped in the pool. Alright, let me just make one up here. I'm trying to be subtle here. Alright, a related rate. See here. Alright, so here's one. All edges of a cube are expanding at a rate of 6 centimeters per second. Alright, so if I've got a cube, that means all sides are equal. Okay? So I can literally just label everything X. Alright? And they're saying that all edges of the cube are expanding at a rate of 6 centimeters per second. So if I'm letting X be there, I'm saying dx dt is 6. And at the word, when it says expand, that's a positive 6. If it was saying it's shrinking at a rate, then I would say negative 6. All right, they're saying how fast is the volume changing? So we're looking for basically volume. So what formula relates the volume and the sides of a cube? Well, the volume of a cube is volume equals x cubed, right? X times x times x. So they're wanting to know the volume changing. So that's dv dt is what I'm looking for. The snapshot is when each edge is 2 centimeters. So when x is 2. All right. Now, here's my, let's differentiate this guy. The derivative of v is 1 dv dt. The derivative of x cubed is 3x squared dx dt. All right, let's plug in what we know here. We know x, and we know dx dt. All right, so we got 3 times 4 times 6. Okay, so So 12 times 6, 72. That's our dV/dt. Okay. Is that okay, Mark? I wouldn't say it's difficult. It's just different. I think you all can kind of agree they're easy when I show you. So it's just a matter of understanding what they're asking. Okay. Let's see here. What's another one here? Yeah. Area of a circle. All right. The radius r of a circle is increasing at a rate. Again, that you interpret that as dr dt. Radius is increasing at a rate, okay, of 4 centimeters per minute. Again, it's increasing, so we use a positive 4. Okay. Find the rates of change of the area. All right. So that means dA dt. Okay, the rate at which the area is changing when r is 8. Now, what formula relates area and radius together of a circle? Well, duh. Area equals pi r squared. So dA dt is what I'm looking for. Derivative of that is 2 pi r dr dt. Okay, we know r and we know dr dt. Okay, so we get 32, so we get 64 pi. Okay, again, piece of cake when you kind of see it done. The guys are all pretty much the same way, and I'm not going to give you anything very very difficult. Now, we're not done with related rates. We're going to do some more stuff from chapter 2, and we'll do some more difficult related rates. I'll have another worksheet and we'll do some more difficult ones, but I think your first stab at this on a test, we're going to keep it kind of simple. Areas of circles, Pythagorean triangles, area of triangles maybe, and so forth. Okay, so any other questions here? Okay. Like I said, the test, there's a bunch of them where, I give you something like this. xy equals 4. dy dt. You're going to find that when x is 8 and dx dt equals 10. Okay, so this is a related rate without the question, without a wording paragraph or something. Okay, so this is product rule. Guys, you need to make sure you brush up on your differentiating rules. Okay, make sure you know those. And I don't go goofy. I don't, go nuts with it, but you need to know them, all right? So the derivative of x is 1 times y, all right? And then, dx dt, all right? Because it's everything's with respect to time. So even if I differentiate an x or a y, I'm going to have a differential there. Plus, the derivative of y is dy dt times x equals 0. All right, since I've got values, I'm going to go ahead and plug everything in. All right, now they tell me what x is, but I need to know what y is. All right, so you can do a little quick scratch work here. When x is 8, so 8y equals 4, y is 1/2. All right, so you may have to do a little scratch work like that. All right, so dx dt is 10, y is 1/2, plus x is 8. dy dt is what I'm looking for. Half of 10 is 5. I move 5 over, so I get negative 5 over 8. All right. So there's several of these. It's kind of related rates without the paragraph. Then there's just some plain old implicit differentiation, something like this. Okay, I'm not giving you any values, just tell me this answer right here. And then of course the related rates are the word problems, okay? You know, something like this. And again, I verbally said this, but you can go back and re-listen to that, okay? All right, guys, it's 9 o'clock. I'm going to go put my little guy down to bed. You guys are going to be fine. Don't get nervous. Don't overthink it. Don't second guess yourself. It's exactly what we've been doing in class, okay? All right, guys, have a good night.